Today we're going to cover the least common multiples and the greatest common factor. The least common multiple is the smallest positive number that the two numbers can divide into. Now what's interesting about that is the least common multiple is actually going to be bigger than your original numbers. The greatest common factor is the largest positive number that can divide into the two original numbers. Now that number is actually going to be smaller than your original numbers. Another way of thinking about the greatest common factor is that's going to be the largest shared factor. And we'll get to that in a minute. But right now we'll talk about the least common multiples. We'll find the least common multiple first. I have two different methods. The first method is by multiplying integers. This step is simple. Simply multiply each number by integers 1, 2, 3 until you find the same number twice. So let's take 6 and 8 to begin with. I'm going to multiply 6 and 8 by the integers. So times 1, times 2, 3, 4, 5. You get the idea. 6 times 1 is 6, then 12, then 18, 24, and 30. 8 times 1, 8, 16, 24, 32, 40. Now what you're doing is looking for a common number. Here, the common number is 24. That means that your least common multiple for 6 and 8 is 24. So that equals 24. Next, 30 and 45. So 30 times 1 times 2, and then do the same thing for 45. Now right here I can already see I have a match, so I don't have to keep going. I can just stop right there. Our least common multiple is 90. So our least common multiple is equal to 90. Moving on to 4 and 6. We see what numbers work together. I have 12, and there's also a 24. We're looking for the least common multiple, which means the smallest number. So my answer here is going to be 12. Now I've got 10, 15, and 25. Now, if we wanted to, we could write 10, 20, 30, etc. all the way down. But I'm going to start with the biggest number because that's the one that's going to be the most difficult. So I'm going to have 25. That's probably going to be big enough. Now I need to look at 10 and 15 and figure out if any of their multiples will come out to one of these numbers on the right. The long way, I can write them all out, but there's actually a shortcut to that. Because 25 is so much bigger, I know that 10 and 15 are going to be the same number when they multiply. 10 times 15. Well, 10 times 15 is 150. That means my least common multiple is going to be 150. The steps for the second method are pretty similar. Find the prime factorization of each number, so we're going to use the primevary tree. Compare prime factorizations and simply multiply one of each factor. The first example we're going to go over is 30 and 35. We need to factor those, so I'm going to use the factoring tree. 30 breaks into 3 and 10 breaks into 2 and 5. 45 breaks into 9 times 5, and then 3 times 3. Now I'm going to list the factors sideways. 30 had 2 times 3 times 5. The 45 had 3 times 3 times 5. So they both had a 5. They both had a 3. But then the 45 had an extra 3. So I'm just going to go ahead and throw that in the front. Now what we need is one of everything. So I'm going to go ahead and separate them just to make it easier to see. And then I'm going to want one of each piece. So I have a 3, I have a 2, I have another 3. There's duplicates that only need a single. And I have a 5. Again, duplicates, I only need a single. Now what you do is simply multiply those all the way through. 3 times 2 is 6. 3 times 5 is 15. 6 times 15 is 90. Now you don't have to do the primary tree every single time, or the factoring tree, if you know that 12 breaks up into 2, 6, and 6 breaks up into 2 and 3, that's fine. So I know that 12 breaks up into 2 times 2 times 3. But if you don't know exactly how they break up, then you do want to do the factoring tree. Now I need to put those underneath the others. I'm going to start at the beginning. I have a 2, I have a 2, but then I have an extra 2 and an extra 2 and a 5. I'm going to break up my columns so that they're easy to see, and I need 1 from each column. That means I'm left with a 2, a 2, a 3, another set of 2s, and a 5. Well, 2 times 2 is 4, 3 times 2 is 6, and 2 times 5 is 10. 4 times 6 is 24, and 24 times 10 is 240. So our least common multiple of 12 and 80 is 240. We can do the same thing with larger numbers if we want to. Again, I don't need to do the factoring tree for 10, 15, and 25. I'm just going to do them each separately. 10 breaks into 2 times 5. The 15 breaks into 3 times 5. So I have a matching 5 and then a 3 with no home. And then the 25 breaks into 5 times 5. So I have a 5 and then I have another 5. Now we're going to separate them into our columns. I have a 3, I have a 2, I have a 5, and another 5 column. So that would give me 3 times 2 times 5 times 5. Well, 5 times 5 is 25, 3 times 2 is 6, 6 times 25 is equal to 150. And you can do the same thing with the 6, 9, and 24. I'll just run through it really fast. 24 is going to be that leaves me with a 2, extra 2, an extra 2, and a 3. Now we're going to want one of each of these. 3 times 3 is 9. 2 times 2 times 2 is 8. 8 times 9 is equal to 72. Now we're going to move on to finding the greatest common factor. Again, I have 2 methods. The first method is really the best for plain numbers. The second method comes in handy for more difficult problems. So the first method is simply comparing the factors. We were just using the primary tree, so we'll continue to use the primary tree. I have a 20 and a 30. 20 breaks into 4 times 5, and then 4 breaks up into 2 times 2. 30 breaks into 6 times 5, and then 2 times 3. Now what you want to do is you want to look for like terms. So I have 2 here and another 2 here. Then I also have a 5 and another 5 here. The extra 2 and the extra 3, they don't have partners. We can't use them. You take those numbers and you multiply them. I have the matching 2 and a matching 5, and that is equal to 10. So my greatest common factor is 10. In order to test this, you can do division. 20 divided by 10 is equal to 2. It works. 30 divided by 10 is 3. It also works. That's the check. Make sure that it is actually a factor. Now, a faster way of doing this is if you know your times tables well, you know that 20 breaks up into 2 times 10. 30 breaks up into 3 times 10. I realize these aren't prime numbers, but they are identical factors. So I can see that the 10 matches, the 2 and the 3 don't, and I'm finished. I know that my least common factor, or greatest common factor, is 10. It's a shortcut for smaller, easier problems like this. Again, we have the 56 and the 48. So 56 breaks up into 2 times 28. You don't have to know your multiplication tables. We know that 2 can go into an even number, so I can keep pulling a 2 out of things. Same thing with the 48. 48 breaks up into 2 times 24. Now I look for common pieces. 2 times 2. I have another 2 times 2. And then I have another 2 times 2. So now I just simply multiply them. 2 times 2 times 2 is equal to 8. So my greatest common factor is 8. Now if you do know your multiplication tables, you probably already figured out that 56 can break up into 7 times 8, while 48 can break up into 6 times 8. Right off the bat, I can say I have a common factor. The 7 can't break up anymore, so there's nothing left to factor out. My answer is finished. My greatest common factor is 8. This works for larger numbers also. Now for multiple problems like this, 40, 80, 100, I'm going to use the fastest method I can. So 40 breaks up into 4 times 10, 80 breaks up into 8 times 10, and 100 breaks up into 10 times 10. So I can stop with the 10s right there. Match, match, match. But what about the 4, 8, and 10? I know they can each be broken down farther, so I should probably keep going with them. The 4 breaks up into a set of 2s. The 8 breaks up into 2 and a 4, which breaks up into more 2s. And the 10 is in a 2 and 5. So now I go through looking for another common factor. Here I have a 2 at the beginning, a 2 at the beginning, and a 2 at the beginning. Some of you will say, wait a second, I see more 2s there. That's true, the 40 and the 80 have an extra 2 on them, but the 100 doesn't have any more 2s. So we are finished with that. Your answer is going to be the 2 times the 10, which is equal to 20. Similarly with the 12 and 18, I know that 12 is 2 times 6, 18 is 3 times 6. Take the common terms of 6's, and I have my greatest common factor right there of 6. Moving on to the second method, we need to multiply the factors. Now you still have to find the factors, so using the primary method that we just did is probably better until you get to algebra, and I'll show you what I mean. So we do things pretty much the same. 36, I need to know the factors of those. If you know them off the top of your head, perfect. If you don't know them off the top of your head, then you need to do your factoring tree. 36 breaks into 9 times 4, which gives you a set of 3's and a set of 2's. The 24 breaks up into 6 times 4, which gives you a 2 times 3 and 2 times 2. Set this up across. I have 2 times 2 times 3 times 3 for the 36. And for the 24, I have a 2 times 2, and that matches, and then I have a 3 times 2. Well, I have a 3 there, and then the 2 doesn't match. This should look familiar from up above when we find the least common multiples. But here, I'm only trying to find the factor. So I'm looking for the pieces that are the same. I have a set of 2's that are the same. I have another set of 2's that are the same. And I have a set of 3's that are the same. So you simply bring those down and multiply them. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is equal to 12. Now, if you have to do the factoring tree anyway, you might as well use the method we did up above until you get to algebra. Once you get to algebra, this is the best way of finding the greatest common factors, and here's why. If I have 6x cubed, that means I have 2 times 3 times x cubed is 3x's. 1, 2, 3x's. Now if I have 9x squared, 9 is 3 times 3. I have one common 3, but then one extra 3. X squared gives you 1, 2x's. Now you want to compare like terms. I have one set of 3's, I have one set of x's, and I have a second set of x's that are all like. I'm going to bring those down. That would give me a 3 times x times x. Well, x times x is x squared. So my greatest common factor of those two algebraic expressions would be 3x squared. Now, if we're only using numbers, I'm going to use the comparing factors method. However, if we're doing algebra, I'm going to be using those multiplying factors method.